Hello and a very good day to our Dr. Nurul Akmal. Today I am Muhammad Akid Shazri bin Muhammad SHAPARI would like to present about our experiment on polarization in a single mode fiber. First, we know that the light waves are natural unpolarized where electromagnetic waves vibrate in more than one plane. For example, light from the sun, candlelight or lamps. On the other hand, the polarization light wave are the light wave which vibrate only on a single plane. So in the experiment carried out by the MIT researcher, they used two methods, which is polarization by reflection and transmission. The They use the helium neon laser to further polarize by transmission method by using linear polarizer, and that can be adjusted manually. The goal of this experiment is to study the polarization light in the single mode fiber and what happened to the polarized light in the fiber if there are any changes in the surrounding. So the experiment setup is like this. First, they have the helium neon light beam transmit to the mirror and then to the quarter wave plate and into the polarizer, and then further to the short focal length lens and then the fiber holder, and then there is the single mode fiber there, and then out from there is fiber holder also, and then transmit to the short focal length lens and to the screen. Next, we can see the results. As the initial result, when the single mode fiber have no interference, the fiber there is no dot will be appeared. And when the force is applied to the single mode fiber, we can see a dot has appeared. So we can say that the polarization of the light in the single mode fiber has been changed due to the mechanical force. As in the discussion, we have made an hypothesis, which is the state of polarization light will be varied when we apply physical disturbance on the single mode fiber. In this case, we use the stress bending or twisting. According to the result, we can conclude the hypothesis is supported and proven. And also in the experiment, we see the laser beam is not disturbed and no red dot of light appeared on the screen. And the polarizer which is set to be on the orthogonal. But when the physical or stress is applied on the fiber, we can see the red dot of light appears. They support the fact that the polarization light has been altered. Further in discussion, we know that the polarization state has been changed due to the phase retardation. The phase retardation started to occur in the progress. A linear polarization could be altered and be retarded. The above figure show that quarter of wavelength has been delayed and the result of forming a circle at the analyzer. And the formula of phase retardation also show that it can be manipulated by the wavelength or lambda. The phase retardation is manipulated by the wavelength. A slight change of the wavelength will result in a huge change of the phase. Thus, the polarization occurs. So, for the conclusion, we can say that single mode optical fiber is widely used in this era of information technology, especially in telecommunication. And through this experiment, we found that the phase retardation occur when there is external disturbance such as deformation and change in temperature. These external factors will affect the single mode fiber directly, bringing the change in the wavelength, which is the phase retardation is inverse proportional to the wavelength. Result the different result when beam on screen. So if we wanted to maintain the polarization state of the light beam, we need to use the polarization maintaining fiber. That's all from me. Thank you.